If we have a circle that is lying on an xy axis, how can we geometrically define this circle? And this can be actually very easily done. We just need to provide two pieces of information. The first one will be the location of the center of the circle. And since we are talking about the xy axis, the location can be very easily described using the coordinates form. So let's say for this circle, the center is here, and its location is actually at the point A, B in the coordinates form. And the next piece of information that we need to provide will be the size of this circle. And the size of this circle can also be described by looking at the radius. So let's say for this particular circle, the radius is R. So let's say this line here is R. Then with this piece of information and this piece of information, this circle is fully defined, which means that the next challenge that we are going to try to overcome is going to be how can we then algebraically describe this circle using an equation. And we talk about the equation of a circle, we actually mean the relationship between the x and y coordinates of a point that is always going to be lying on the circumference of this circle. So let's say that point is here, and the coordinates of that point is x, y. So this point xy will always be lying on the circumference of the circle, which means that the distance between this point and the center of the circle is always going to be fixed at a value of r, the radius of the circle. And in the chapter on coordinates geometry, we have learned a formula that can give us the distance between 2 points. And that is this formula here. It is going to be the square root of x minus x. So x minus a square plus y minus y. So here is going to be y minus b square, and this is of a fixed value of r. And if I were to square both sides of for this equation, we are going to be getting a x minus a square plus y minus b square is equal to r square. And this is the equation of the circle that you will be using now, and you will also be using in the A level. This is a very useful equation because if we are given an equation and we are told that this equation represents a circle, we can very easily try to reverse the equation so that we can extract from the equation the center and the radius of the circle, which means that we will be able to understand the geometry of the circle. Let's take a look at this particular example here. In here, we are given this equation, x plus 2 square plus y minus 3 square is equal to 5. And what we want to know is the center and the radius of the circle that this equation is representing. So what we need to do is to memorize the form, which is actually pretty easy, especially if you were to know how to derive it. Then we are going to try to change this to the form that we have memorized, which means that we are going to change this to, since it's x minus a number, so this will be x minus minus 2 square plus y minus a number, which it already is, so I'm going to leave it as it is, and this is a r square, so I'm going to change this to square root of 5 square, which means that for this particular equation, the center is AB and the radius is r. So for this equation, the center of the circle that it is representing will be minus 2 and 3, and the radius is going to be equal to square root of 5. But in our syllabus, we actually have another equation. Let me show you what is this other equation. That is also going to be one that represents a circle with the center at AB and the radius is r. For that equation, it is actually derived from this particular equation, but it is in the expanded form. So if I were to expand this, we have a x square minus 2ax plus a square. Then if I were to expand this, it will be y square minus 2by plus b square, and this r square, I'm going to move it over to the left hand side, so we have this minus r square is equal to 0. And if I can just rearrange this, x square, then after that y square, and I'm going to rewrite this as plus 2 times of minus ax, and I'm going to rewrite this as plus 2 times of minus by. Then we will have an a square plus b square minus r square as the term that is independent of the variable. Then this is representing the expanded form of the circle, which is what we have here which means that if I have another form of the equation, which is not of this form, but it is of a form that is like this, we can actually, through our memorization of this, to then reverse the effect again to find the center and the radius of the circle. But I have to say that this is not exactly the most easy to memorize, so let me give you another form, okay? It is actually the same as this, except that I'm going to replace minus a by G and minus B by F, and that will get me this equation here, okay? This is actually very similar to this. I'm going to use this equation instead. This one is easier to use, which means that if I am given this other equation, let me show you. If I'm given the equation x squared plus y squared minus 5x plus 8y plus 9 over 4 is equal to 0. I'm making use of the equation that is over here. Let us see how we can then try to find the center and the radius of this circle by making use of the extended form, which this one here is definitely easier than the one that I have here. So what if we were to make use of this? Okay, so what we want to do is to try to re-express this to make it look like that. So it is going to be, okay, I'm going to make it look like that, okay? So it is going to be x squared plus y squared. This will remain the same. And as for minus 5 squared, according to what we see here, it is going to be plus 2gx. Okay, I say it wrongly. It is not minus 5 squared. It's minus 5. So how can we make this minus 5 to become 2gx, of a form 2gx? So this will be plus 2. Then it will be minus 5 over 2 times x, because plus 2 multiplied by minus 5 over 2 will give us a minus 5. But if this is a little bit more confusing to you, for me, I feel that it is okay because I'm just factorizing out 2. But if you find this a bit more confusing, what you can also do, because we are already memorizing that equation, right? So I know that this minus 5 is actually representing 2g. So I'm going to let 2g be equal to minus 5. This will tell me that g is minus 5 over 2. So that will also be a possible way for me to find out what exactly g is representing. So I'm going to do the same thing for this, which is going to be plus 2 times of 4y, or you can also let 2f be equal to the number here, which is 8, which means that f is equal to 8 over 2, it is 4. And now I can also see that it is 4, it is 4y. And then this is going to be, according to the equation, it is going to be plus c, so here it's going to be already a plus, so plus 9 over 4. This is equal to 0, which means that based on this form, which is manipulated from this, we know that g is equal to minus 5 over 2. We know that f is equal to 4, and c here is equal to 9 over 4. And based on what we have now, the center is going to be at minus g minus f. So the center is going to be at minus g, which is 5 over 2, and minus f, which is minus 4. And the radius, according to what we have there, it is g squared plus f squared. So it's going to be this, g squared plus f squared, then minus c. So minus c, c is equal to 9 over 4, and square root of this is going to get us the radius. For this case here, the radius is equal to square root of 20. So we have two equations that are going to be very helpful for us to find to reverse the effect to find the center and the radius of the circle. One is the equation of the circle. The other one is the expanded equation of the circle. Both are going to be useful. Both are going to be tested. Let me show you 3 more scenarios which are very commonly asked in a circles question. So the next one is the chord of a circle. The chord of a circle is this line here, AB. It is a line that is going to be cutting the circle. So for a chord of a circle, it actually has a property that I've stated here. The perpendicular bisector of a chord of the circle is going to be passing through the center of the circle. So this AB here is going to be perpendicular to MC and tangent to a circle. For the tangent to the circle, this tangent, this line, is actually going to be perpendicular to the radius of the circle, PC over here. That is why if this and this are perpendicular to each other, then the gradient of the tangent is going to be equal to negative of 1 over the gradient of the radius. That is going to be from point C to this point P, where the tangent was formed. The last one is going to be talking about the relationship between a point and a circle. And for that, we will usually be asked about whether this point is lying outside the circle, on the circumference of the circle, or inside the circle. We will usually be asked to verify which case it is. And this is actually very easy also, because what we can do is to find the distance between that point and the center of the circle. And if we were to find that the distance is less than the radius, then we will immediately know that this point has to be lying within that circle. But if the distance is exactly equal to the radius, so what should we know? If the distance is exactly the same as the radius, that means that point should be lying on the circumference of the circle. And if the point is going to be of a distance that is more than the radius of the circle, that means that point is going to be outside the circle. Let's look at a question so that we can apply the things that we have just discussed. And that question is this one here. Let's take a look at it. So in this question, we are given a line and we are given a circle. We are given the equation of that line and we are also given the expanded equation of that circle. And the intersection between this line and the circle is going to be at points A and B. We are supposed to find the length of this chord AB. So let me just draw a quick diagram to represent what the question is trying to say. So let's say the circle is this over here. And the chord is, let's say, this, okay? And I'm going to call this point here, let's say B, this point here is A. Let's try to find the coordinates of point A and B. And since it is the intersection between this line and the circle, what we will do for part 1 is to just solve a pair of simultaneous equations. So we have this equation, x plus 3y is equal to 11. I'm going to make x a subject. X is going to be equal to 11 minus 3y. I'm going to call this equation number 1. As for the circle, we are given the expanded form of the equation of the circle. So we have a x squared plus y squared minus 4x plus 4y minus 17. This is equal to 0. I will just simply call this equation number 2. And I'm going to substitute equation number 1 into equation number 2. So x is going to be replaced by 11 minus 3y squared plus y squared minus 4x is going to be replaced by this plus 4y minus 17 is equal to 0. Let's try to solve for y. Expanding this, we will get a 1, 2, 1 minus 66y plus 9y squared plus here we have a y squared. And this is going to be minus 44 plus 12y. Then we have a plus 4y minus 17. This is equal to 0. Simplifying this, we will get a 10y squared minus 50y plus 60. This is equal to 0. Factorizing this, we will get a y minus 2, y minus 3 is equal to 0. And this means that y is going to be equal to 2 or y is going to be equal to 3. And where y is equal to 2, I'm going to sub it back into this equation number 1. X is going to be equal to 11 minus 3 times 2. It is going to be equal to 5. And when y is equal to 3, x is going to be 11 minus 3 times 3. 11 minus 9. X is going to be equal to 2. This will then give me the coordinates of points A and B. So let's say coordinates of point A is going to be at this 5, 2, and the coordinates of point B is going to be at 3, is going to be at 2, 3. So let me just change this. The x is 2 and the y is 3. And with the coordinates of the 2 points that I've just found, we will then be able to find the length of the chord AB. It is just the length between A and B. So we are going to once again use the same formula from coordinates geometry. So AB is going to be equal to square root of x minus x squared plus y minus y squared. So it will be 5 minus 2 squared plus 2 minus 3 squared. And AB here is going to be square root of 10. So this is the distance of the chord AB. Let me just indicate the coordinates of A and B here. So this is at the point 5, 2, and BB is at the point 2, 3, which we have just found. Let's move on to part 2. And in part 2, we want to show that the perpendicular bisector of AB is going to pass through the center of the circle. So we need two things in order for us to do this. Number one is the equation of the perpendicular bisector of AB. The perpendicular bisector of AB will look something that is like this. Okay, it is 90 degrees here, and it is this point here, which is the midpoint, is going to be the same distance away from point A and B. So this is the first equation that I need to find. The first information that I need to find, the equation of the perpendicular bisector. The next one, okay, the next one is not actually an equation. The next one is a geometry of the circle, which is the center of the circle. We want to verify whether this line here really passes through the center of the circle. I'm going to just draw it here first, okay? Because we know that this is true. We just want to verify it. We have just discussed about it. The perpendicular bisector of a chord is actually going to be passing through the circle. So let's verify it using this question here. Let's try to find the perpendicular bisector of this line AB. I am going to call this center, this midpoint here as M. Again, making use of what we have discussed in the chapter on coordinates geometry, we can find M, we are doing part 2, we can find the coordinates of M. That will be x plus x divided by 2, y plus y divided by 2. So 2 plus 5 divided by 2, 3 plus 2 divided by 2, which means that the coordinate of point M is going to be 7 over 2, 5 over 2. And what we want to do next is to find the gradient of the line that passes through AB. I'm going to call the gradient as M. So M of AB is going to be equal to, let's use the formula to find gradient. So I'm going to take y minus y divided by x minus x. So it is going to be 3 minus 2 divided by 2 minus 5. So the gradient of the line that passes through AB is minus 1 over 3. So the gradient of the line that is perpendicularly bisecting AB will be negative 1 over this. So negative 1 over this will be positive 3. So now we can form the equation of the perpendicular bisector of AB. And that will be y minus the y coordinates of M, since M lies on this line. So y minus the y coordinates of M is equal to the gradient of the perpendicular bisector, which is minus 1 over the gradient of the chord AB. So this is like what we were saying just now, this is equal to 3. So it will be the gradient of the perpendicular bisector, which is 3 of x minus the x coordinate of M, 7 over 2. And this will give us the equation of the perpendicular bisector, y is equal to 3x minus 8. And okay, we have gotten our first piece of information. The next one will be for us to determine the center of the circle. The equation of the circle that is given to us is x squared plus y squared minus 4x plus 4y minus 17. This is equal to 0. So this is the expanded form, which means that if I want to reverse back the effect to find the center, I mean, we don't really need the radius, but if we were to find the center and the radius, what we need to do is to just re-express this into the expanded form that we have discussed just now. Let me show it here. So we're going to try to go for this form here. Okay, so let's try to rewrite this. So this will be x squared plus y squared plus 2 times of minus 2x, then plus 2 times of y. Then this is going to be plus minus 17 is equal to 0. So now that it is in that form, we can then know what is g. G is minus 2. We know what is f. F is 2. And we know what is c. C is minus 17. So from here, we will then be able to find the center and the radius of the circle. The center of the circle is going to be at minus g, according to the formula that we have there. So it's going to be 2, then minus f, which is going to be minus 2. And the radius of the circle is square root of g squared minus 2 squared plus f square, so 2 square, minus c, so minus 17. This is going to give me a square root of 25, and this is equal to 5. Okay, can I just tell you my preference? Because my preference is not to be using this equation, because I find this equation harder to memorize. The one that I find for myself personally that is easier to memorize is actually this over here. So what I can do, okay, my personal preference, although this is actually really fast, okay, so if you guys can have no problem memorizing this, okay, then please just go for this form, okay, but I'm going to just go for this. I'm going to show you how I can also try to use the equation of the circle instead of the expanded equation of the circle. What I'm going to do is I'm going to take this, let me just rewrite it, x squared plus y squared minus 4x plus 4y minus 17 is equal to 0. And I'm going to do a completing square to this equation. So if I were to complete square, I'm going to go for this to be together. And this one here, I'm going to group it together, minus 17. I'm going to just move it over to the other side for now. So completing square to this, it is going to be x minus 2 square minus 2 square. Then completing square to this will be y plus 2 square minus 2 square. This is going to be equal to 17. So what we have now is a x minus 2 square plus y plus 2 square is equal to, if I were to bring this over to the right hand side, this is going to be equal to 25. Which means I can then re-express this as x minus 2 square plus y minus 2 square is equal to 5 square. And based on the formula that we have, this is with a radius of, with a center as 2 and minus 2. And the radius is equal to 5. We're actually getting exactly the same thing. So it really depends on you. It depends on your preference. You know, I think this is fine. In fact, I think this is good for most people. But if this goes well for you better, might as well just go for this. But regardless of that, regardless of whether it is this or this, we are still going to be deriving at the same center. We are still going to be deriving at the same radius. So let us now verify whether the perpendicular bisector is really going to be passing through the center of the circle. Let's switch back to the question that we have just been discussing. So is the perpendicular bisector really passing through the center of the circle, like what we have discussed previously? Let's try to verify. So the equation of the perpendicular bisector is this. So based on this, so for the perpendicular bisector of AB, which is y is equal to 3x minus 8, when, okay, the center is this, 2 minus 2. So when x is equal to 2, let's check whether the y is minus 2. So when x is equal to 2, then 3x minus 8 is 3 times 2 minus 8, which is minus 2, and that is the same as the corresponding y coordinate for the center of the circle. Therefore, the perpendicular bisector is going to be passing through the center of the circle. That's what we have verified. Next, let's move on to part 3. In part 3, what we want to do is to find the equation of the tangent to the circle that is passing through the point A. So we are going to try to find the tangent. So let's say the tangent is here. Okay, I mean, it is a bad diagram, okay, but this is like really pretty bad. But according to what we have discussed just now, we know that the tangent is supposed to be perpendicular to the radius. Okay, this definitely doesn't look like perpendicular, but let's assume that this tangent is perpendicular to the radius. Okay, in fact, it does look a bit more, I mean, okay, it's not that bad, okay, I mean, as I were to look at it again, it is actually pretty perpendicular. So anyway, we want to look at this tangent to be perpendicular to the radius. I'm going to make use of this to find the equation of this tangent. So let's say the center of the circle is C, and we have found out about the coordinates of C just now. The coordinates of C, we found that it was 2 and minus 2. So what I'm going to do is I am going to try to find the gradient. Let me use m to represent gradient. The gradient of this line AC, the gradient of the radius. So the gradient of this is going to be y minus y divided by x minus x. So it's going to be equal to, let's say, minus 2 minus 2, minus 2 minus 2 divided by 2 minus 5. And this will give me a gradient of 4 over 3. So the gradient of AC is 4 over, the gradient of the line that passes through AC, the gradient of the radius is 4 over 3, which means that the gradient of the tangent is, the gradient of tangent, which is perpendicular to AC, will be minus 1 over 4 over 3, which is minus 3 over 4. This is the gradient of the tangent. So based on this that we have here now, we can then find the equation of the tangent that the question is asking for, and that will be y minus the y coordinate of a point that is on the tangent, which is 2. So 2 is equal to the gradient of the tangent, which is minus 1 over the gradient of the radius, since they are perpendicular to each other, and I know that it is going to be equal to minus 3 over 4, and x minus away the x coordinate of a point that is lying on the tangent, which is the x coordinate of point A, so x minus 5. And this will be y minus 2 is equal to minus 3 over 4 of x minus 5. And the equation of this tangent is y is equal to minus 3 over 4x plus 23 over 4. And the last part, part 4, we want to verify whether this point P is a point that is going to be lying on the circle or not, which means that we are trying to determine whether this point P lies on the circumference of the circle. So this point P has a coordinates of 5 minus 1. What we want to do is to check the distance between P and the center of the radius, the center of the circle, and we want to compare it to the radius. What was the radius that we found just now? The radius was 5. Okay, let's take note. The radius was 5. So let's take a look at the distance between C and the point P. P was given to us. Let me just quote it here. Point C has a coordinate that is 2 and minus 2. And point P has a coordinate that is now given to me by the question as 5 and minus 1. So the distance between these 2 points gives me CP, and the distance is x minus x. So 2 minus 5 square plus y minus y. So minus 2 minus minus 1 will give me a plus 1 square. So this is going to be equal to square root of 10. And square root of 10 is, I think, is 3 point something. Let's just do a quick verification. So square root of 10 is equal to 3.16. So 3.16 here is less than the radius that we have found just now. It is 5. And therefore, what can we say? Can we say that P is not lying on the circle? Yes, in fact, P is not lying on the circumference of the circle. In fact, we even know that P is going to be lying within the circle. But anyway, just to answer the question, we now know that P does not lie on the circle. Okay, that is all I have for you on circles, and I'm going to see you in the next chapter.